All right. I'm ready, I believe. All set up. Sweet. Okay, let's make the font a little bigger. I'll leave this one a little smaller. I'm gonna try to use Vim today, because I do have the tools set up. I don't know all the keyboard shortcuts to work with the Rust Analyzer and all the, toggling the inlay hints and all that stuff. So there may be some struggling there. But anyway, happy Sunday. I am a little behind on Advent of Code. Let's open it up. So we're going to do day 7 today. Your all expenses paid trip turns out to be a one-way 5-minute ride in an airship. Did you bring the parts? I turn around. You turn around to see an elf completely covered in white clothing, wearing goggles and riding a large camel. Did you bring the parts? She asks again, louder this time. The parts. At the sand, yes, come with me, I will show you. Normally they use big machines to move the rocks and filter the sand, but the machines have broken down because Desert Island recently stopped receiving the parts they need to fix the machine. You already assumed it'll be your job to figure out why the parts stopped when she asks if you can help. Because the journey will take a few days, she offers to teach you the game of camel cards. Camel cards is sort of similar to poker, except it's designed to be easier to play while riding a camel. Of course. In camel cards, you get a list of hands. Your goal is to order them based on the strength of each hand. A hand consists of 5 cards labeled Ace, King, Queen, Jack, 10, 9, 8, 7, 6, 5, 4, 3, or 2. The relative strength of each card is followed. A is highest, 2 is lowest. Every hand is exactly one type. From strongest to weakest, they are 5 of a kind, 4 of a kind, full house, 3 of a kind, 2 pair, 1 pair, high card. I'm pretty sure I did this as like a poker hands kata a long time ago. In a screencast, actually. I think it was something like that, but it was actually poker rules. This is definitely simpler. Hands are primarily ordered based on the type. Every full house is stronger than any three of a kind. If 2 hands have the same type, the second ordering rule takes effect. Start by comparing the first card in each hand. If these cards are different, the card with the stronger card is considered stronger. The first card in each hand has a stable label limit on the next one. Okay, so it's 3, 3, 3, 2, and 2 ace, 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 ace are both 4 of a kind. But 3, 3, oh, okay, that's different. Got it, okay. To play camel cards, similarly 7, 7, 8, 8, 8, and 7, 7, 7, 8, 8 are both a full house, but 7, 7, 8, 8, 8 is stronger because his third card is stronger. To play camel cards, you are given a list of hands and their corresponding bid, your puzzle input. Okay, we'll take that. Let's move it over here. Let's do CFG mod tests. Let's see, test sample input. That will be a function. That will be a test. We are going to use indoc. I think it's indoc, so that I can do let input equals input equals indoc bang quote, and we can move that over, and we can paste this and make it lined up all nice and neat. Okay, so that's our sample input. We're gonna first start by parsing this into hands. So we'll have a struct for a hand. A hand is gonna have 5 cards. I think I also want to have a struct for a card. This is going to be the character value, maybe a value. And a hand is going to have exactly 5 cards. So here we can do the array of card and 5. Okay, so I'm going to go over here. I'm going to copy the, actually, let's do it this way. Let's go over here. I'm going to copy this and paste it here. So now I can do just build, just run, just test. Just build. And we can also do that with, if I do it with just watch part 1, then it will do this. Okay, I think I need a semicolon there, not a comma. Something is going on with the stream. I'm not sure what. There it goes. I don't know what happened to the to the stream. It dropped down to like 100 kilobits. Super weird. All right. How is that? Is that visible? I'm gonna make it a little bigger. Okay, I need a semicolon there. And okay, now we have, I'm gonna do allow dead code so we avoid the warnings. Do I have to do it on the whole thing? Then unused imports. So our part 1, oh, I'm doing all this in the bin. I didn't mean to put that here. Let's move this over to the actual code here. Okay. Okay, so now this is an unused import on this guy. So here we're going to say let input equals include stir input.txt. Then we will say part 1 let answer equals process input. And then here we will do that answer. Okay, unused variable input in the test, that's fine. We can close that one and that one. Okay. Here we're going to say let answer equals process input, and then we would assert equal that the answer is equal to, and in this case, this example shows 5 hands. Each hand is followed by its bid. Each hand wins an amount equal to its bid multiplied by its rank, where the weakest hand gets rank 1, second weakest hand gets rank 2, and up to the strongest hand. Because there are 5 hands in this example, the strongest hand will have rank 5, and its bid will be multiplied by 5. Okay, so we'll sort them, then we will multiply them by the rank, and then do you add them up? Yes. Total winnings are 6440. So we will make that into a string, 6440. Okay, so now can't find process because it needs to use super star. Okay, so now we have no warnings and we're running the test, which is what we wanted. Okay, so before we get to this, let's make sure we can test parsing our input. I'm gonna do test parse card. And going to take parse card, and then we're going to do 32 T3K. And then we want that. We're going to use nom again for this. So I don't know actually if we need to use nom now that I think about it. This one is just pretty simple. Okay, and then we will expect the results. And then here I can say assert equal card dot oh wait, each one of the, sorry, this needs to be parse hand. This is going to be a hand. That's going to be parse hand. And then we're going to do hand dot cards. Yeah, that's going to be parse hand. Okay, so we expect this now to be an array with exactly 5 characters in it. 3, 2, 10, 3, and K. All right, so let's implement the parse hand method. And this can return an option hand if it didn't match, but I wonder if I should just, yeah, I'll leave the parser a little bit more resilient. Where is my fan? Hang on. Okay, so parsing the hand, we're going to read in up to the end of the line. So we're actually going to assume that this is just one line of text. And so then we can do hand.characters, or sorry, input dot is it chars? Let's derive debug on this and the hand. Okay. This is going to be a card. Each one of these is going to be a card with, let's do this, card open val colon. Then I will go here, there. Oh, that didn't work. So we'll do that, this, that, go here, then close it, and then add Q, add Q, add Q. Oh, this isn't working. It's close. That goes here. Okay, so then we need partial equal for card, because we want to be able to compare them by their character. And we will probably have to implement that ourselves so that we can compare the values as we want to. Okay, so here I can take that chars, we can map this to card parse. Let's do parse card. I probably could have done this on the types themselves, but Okay, and then we want to filter map these on parse card because, and this gives us our cards. And then I want to return a hand with cards. Let's see. Oh, it has to be exactly 5. And so this doesn't know if it'll be exactly 5. So if it's not exactly 5, I should probably bail. We can assert that cards.count is equal to 5. Actually, now that I think about it, I wonder if part 2 is going to give us hands that are much bigger. That's probably what part 2 is going to be. So in this case, I think instead I'm going to do a vec. Vec of card, because that way we can just make that a lot easier. So this one is going to be .collect. We'll collect into a vec. And then here, this does not return an option anymore. No reason to do that, so we can just do parse hand, return a hand. Parse card doesn't exist, so let's do fn parse card. And that's going to take the character and return a card. Here I did want to do an option because I want to switch on, I want to match on C. And if C is, I wonder if I can do a range. 1 to 9. Then we'll do card val C. That needs to be sum card val C. And exclusive range. Oh, I want that to be like this, maybe? Okay, so it's non-exhaustive now. So now we need to include more, and I think I could do this with multiple ranges. Let's find out. Can I do A? No. I don't want to match on a tuple. Let's see if I can find this out. Rust match multiple values. Zero or pipe character. A king. Let's see if that works. Oops, I need an or king, or jack, or queen. Or 10. And then in any other case, we're going to return none. So let's be underscore equals none. Need a comma here. Okay. It doesn't think parse hand is being used because it's only using a test at the moment. And also I don't need to expect that there's a hand here because we will always get one. Okay, so our tests, it ran 2 tests, and 1 passed, 1 failed. So now the question is to figure out what the type of a card is. Not type of a card is. I think maybe what the rank of the card is, that would work. So if I did impl, do I want to do like this? And then when I create it, I just have it? Probably. That way I can just parse it one time. Okay, so I think I'm going to do this. So this is now going to give you some card with a I don't like the name Val, but this is going to give us, that's C, and the rank is going to be parse C.parse. .expect unwrap, because we know it's an int. Okay, so that's 1 through 9. Then if I do an ace, then I get some card with the val of A. Well, they're all going to be val of C. This one is going to be a rank of, let's see, 10, 11, 12, 13, 14. And then that's going to be king. This will be 13. Queen, 12. Jack, 11. And T is 10. Okay. So then I need here. No, not there. That is in 59. So here we're going to do rank 3. We'll do the same here, and okay, that's going to be 2, 10, 3, and 13. Parse not found. So do I need to convert that to a string first? Okay, so now we're back at a passing test, but now we've included the rank for each one of the cards. That will allow us to sort them properly. I want to have some sort of detector function that can detect a given hand. So, and then I can have an array of detectors. Yeah, so if I have a detect function, that would return, let's do an enum for hand type. And this is going to be high card, which I don't think we need to care about what the high card is. So we'll do pair, 3 kind, 4 kind, and 5 kind. So if we have this, and then we can detect, we have a detect function for detect pair, let's say, and then this is going to take in the hand, and we can borrow. And then this is going to return whether or not it is a pair or not. So if our detector functions all look like this, then we can just run them in order and find the first one that matches. So how do I do a function? Let's see. Rust type alias function. I think it's just this. So if I did type detector equals a function, actually I don't know if that is what I want. A function from hand option reference to hand to bool. That probably is not what we want. These should have upper camel case. Okay, high card, pair, 3 kind, 4 kind, 5 kind. I can't find bool because it's lowercase. Okay, so if I have all these detectors, then we can impl hand, and we can say best hand type taken in self, and this will return a hand type. And here we can say detectors is an array of detector which has detect pair in it. And then we can say detectors dot first. We would need to iter. Into iter is fine. First, or find. I think it's find. And then this will be the detector. And we'll call it on self. And then that should return, if it's a pair, so I think this needs to be detector and hand type. Something like that. So we'll have a function for each. This needs to be okay, so this one, it might not find any, and if it doesn't find any, this needs to be, can I do that? Oh no, this is going to be unwrap or, and then at that point we're just going to say high card. So let's do that. We'll do into iter, find the first one that matches, or high card. And we don't need to test for high card because it will always return true. So that'll be hand type high card. And we need to map this to, yeah, so this detector is going to be detector and the type. And then we can map that to just the type. Okay, detectors does have a size known, so we can tell it that we want, is it 5 types? No, it's going to be 1, 2, 3, 4. So there's only going to be 4 in here. So we can just say that there's 4, and let's give it to them. Okay, detect pair, we'll just do 4 of those. This one takes 2 arguments because I need to wrap this in a tuple. Yeah, I don't care about the type in this case, but I do when I map it. Okay, so at this point now we've got a best hand type. And we're going to say detect kind 3. Oh, sorry, 5. Detect kind 4. This will be interesting. Detect kind 3. Detect kind 2. Ooh, that's interesting. All right. So instead of this, it's going to be detect kind is going to take in a count, which will be a U32. And that's going to return a detector. Oh, we have full house and stuff too. I forgot about those. What are our types? Full house. No, that's the only one I'm missing. So it's high card, 1 pair, 2 pair. Oh, okay. 2 pair. 3 of a kind, then full house. Then 4 of a kind and 5 of a kind. Okay. So we will have more. I don't know how to return a function. Let's see. Rust return function from function. Closure. That's what I want. Okay. Okay, so this is going to get a little bit interesting. I need multiple detectors that will take the input and return it. So this one is actually going to be different because I need to detect, similar to how nom works, I would have to say, like if I'm going to get 2 pair, I can't just search for pairs twice because then I would have to know what the pair was so that I don't include that in the second one. But if we eliminate those cards from the rest of the checking, then that would work. So what I think I want to do, so this detector function is going to get a little bit more complicated. But if I said detect 2 pair, then I need to have a reference to all the cards. Cards, which would be a vec. Well, actually, we could just make this a slice of card. And this would return bool. But it would also return the slice of cards that we have yet to parse. So I'm going to do this similar to how nom does it. So we can do an array slice and a match. So if I can do that, then I need to say detect kind, and that is going to take the count. And let's just do this rather than the functional style. We'll take the count and the cards, and we will return if we matched the same number of that card, and if so, we'll remove it from the list and return. So then this one would be, assuming that this one worked, let's get rid of this one. And I'm not sure what the detector will look like yet, but actually this one will probably just take cards. Slice of card, array of cards. Okay, so if I had, let's say detect let's say that worked. Then detecting two pairs would say detect kind 2 on cards, and that would give us the remaining and the whether it's true or not. So we could actually match, maybe. If I did match detect kind 2 and cards, then we would get the remaining and true. So if it worked, then we have the remaining cards. Then we can detect kind here, pass in the we don't care about, or it's going to be 2 and the remaining. And then this one, I think I would need to match on that also. I think match might make this a little less. Match might make this a little less readable. Let me start with just doing it like this. So we'll say let remaining and match is match, or found. Let's do that, found. So we'll do that. This is going to be detect kind on cards. And then here, if found, then we're going to say we don't care about the remaining, and we can overwrite found here, I think. Equals detect kind 2, and that's going to be remaining. That needs to be just an equals. Okay, and then at the very end we return found. But that won't work because I would have to do it here. I don't quite know how best to do this. I was trying to do this in just a couple of lines because I'd like to just compose these together. Yeah, there's probably some. I think what would end up happening is this is going to be very similar to very similar to the design of Nom, where you build up the parsers and then you call it with cards. But here I'm doing it like this. So I think that these parsers would, right? So this would, instead of detect kind taking both, it would then return a function that took cards and returned that. And I don't think we can name it. We just give it like that. Let's see, function that returns a function. Impl function. Oh, okay. I was reading the question, not this one. So if I did, this returns impl function that takes that and returns that. Okay. Let's see. Could I make that work? Go to the top and make sure that we have this correct. So line 30, detect kind, expected function, closure but found empty. But that's because I did a to-do. Why is it? and then returning so then that would be move count, and then I can return the closure like this, and this would be yeah, I'm kind of struggling with the rest here. If this was Swift, I think I would probably go for something more fancy. But I don't know if I know how to do this. So this would be move count. That's not move count. That's move cards. Cards would move into here. And then I could say cards dot I'm not quite sure what I would want to do here, but maybe I could just return cards and false as a stand-in. That actually did work. So this kind of detector needs a type alias, should have the thing here. Okay, so detect to kind. So this one, instead of being that, would be composing to. So this would be compose one detector with another detector. So that would be this one, and then the remaining one. So I could do detector and then D2 detector, and that returns a new detector, which means that this thing can be returns detector to simplify, I believe. So here we can run, we're going to return the same thing where we move cards in to here. Then we run it on D1. We pass in cards. Then we say remaining and found equals D1. If found, if found, then we're going to say let remaining and found here equals D2 on remaining. And then here's where I want to return. We want to return remaining and found. We just want to return D2 actually. If found, we return D2. Otherwise, we return cards and false. And none of that. Okay, so interestingly enough, that this seems to be compiling. So now detect to pair is going to, again, it's going to take nothing and return a detector. And this is going to be compose of detect kind of 2, and then do that twice. I don't know what is happening here. Okay. Escape wasn't working there. All right, so if I do detect kind twice, now I've got a composer that can detect this, pass the results to that, and then detect again. Okay, I want to kind of clean up this one because now I think that these are going to be a little different. Can I do this and just have it figure it out? I don't know. Actually, I think I can just omit the type. and let the compiler figure it out. I think that's what I want. Okay, so this is going to be a detect to pair, which gives me a detector. And then I want that to be linked up with to pair here. Okay, so then I can go into each detector, then we find it, then we need to find the first one that returns true, but it returns true on the cards. So here I need to just take, if the detector returns a tuple, so I need to take .1 there. Two pair, hand type two pair. Not sure what happened there. Hand type, not a type. Okay, let's go to the top and see. Oh, that is the top. Expected type, found function, detect two pair. That needs to be equals, that's why. What happened here? Expected bool found. Why did it expect a bool? Because the detector, this one needs to return the remaining cards and bool. Okay. Now compose has mismatched types. Expected a function pointer, found a closure. I think I want this. No. Okay. I don't want that. Let's see. I mean, I could make them all return what we think they should be. So if I left it like this, and on compose, I just returned impl function, which takes a card slice and returns a tuple of card slice to bool. Does that complain? It seems like compose is now fine. And then this one has the same problem. It is possible to return closures inside a box, that is, as trait objects implementing a certain trait. Do I want that though? When was this written? This is 2014. Is this still relevant in modern Rust? I don't know. Okay, so I don't know if I need the impl keyword, but I don't know the difference between this capital FN. Okay, so this is all making sense because it needs to be some dynamic type, and it's not going to know the shape of it. Expected function pointer found opaque type. I'm just not sure why function pointers and closures don't have the same signature. Rust, type alias, closure. And let's also look at this one. So f is a function that has a generic argument f, which is an fn once, that returns a string. And then it takes an argument g, which is of type f, and then it invokes the function. So then when you call it, you can pass a closure with the pipes because it doesn't take any arguments. Fn does not define a closure type, it defines bare function pointers. Okay, that's why you can't assign a closure to that. Instead, you want to use either fn, fn mute, or fn once. Okay, so, but if I did fn, it wants it to be dyn. Trait objects must include the dyn keyword. There are a few more changes to make this compile on minimize. The f parameter you wrote receives an unsized type by value, which is forbidden. You also put f type parameter you don't use. You probably meant to constrain f and use type as f. Okay. The compiler won't let us use a type alias in a type parameter constraint. We need to spell out the trait fully. This means the type alias is basically useless. Okay. I was hoping to use this, but I don't think that that helps me any. So if we change this to... Oh, I feel like there has to be a way for this to work. I also don't quite understand why, if I say dyn function, the closure itself is just a pointer to a function. The arguments to the function are all the same size. The trait size is not implemented for a dynamic function. You can use impl trait as the argument type. I can do an implementation. Type alias cannot be used as traits. Okay. Oh, I really want this to work without having to copy this everywhere. So if I do that, that part should work. Let's see, this one needs the opening. Wait, what does that return? Fn. Okay, so then if I do this, This is going to be really hard to read. So detect kind. So then, it's interesting. Oh, that one says impl, that's why. D1 is this. And so it's also saying here that this needs to be dyn. And this one also. No, wait, but I can use impl here when I take these as arguments because I'm no longer using a trait. Detect kind. Do I need impl here? So the compiler, I guess, will figure it out. Okay, I'm gonna keep going. So that's gonna take card and return a card and bool. And can't, let's see. What is it complaining about here? This is one thing that I'm not great at with Vim is the LSP stuff. Look at the quick fix and okay, count is unused, sure. Let's just get rid of that for the moment. Then opaque type defined here. Maybe it's because it was called somewhere else and thinks it needs to be a detector. Okay, so here I found a hand. So we're gonna do self.cards. And that found a vec of cards, but we can just take the slice of it. And now we are compiling. Amazing. That took a while to wrestle these types. Okay, so now I want to test that I can detect. Let's do test. I want to do test detect pair. And so I'm going to create a vec of cards. This is going to be, let's do 3, 5, 3, 8, 1. Okay, so those are our cards. We're going to get the chars, and we're going to map those to C dot, or this is going to be parse card. That needs to be filter map. Can I pass it along just like that? I think I can. And then that now needs to be collected into a vec like this. Oh, I need this whole thing into generic. Okay, so now I've got a vec of cards, and now I want to assert equal that it does parse the cards. So we're going to do actual and expected. So the actual result is from detect kind to is going to be a string slice of, not string slice, card slice. So the remaining cards are going to be something like card with a value of 5, rank 5. The 3 will be eaten, the 8 will come out, and then we'll have a 1. Okay, so then the other part of this is going to be true, that we expect that it matched. Okay. We need to actually call this on cards. And we need to pass a vec. A slice. Okay. Let's get rid of this warning here. We're going to say allow dead code. Also on here and here, and then on the enum. Okay, the detector is gone. Now we expect a card pool found card. Do I then need to just do a vec and a string slice to that? I think that's what I need. So that needs to be a vec. But then I'm not sure how that works. That still returns a vec. If I do this, does that work? No. I need to compare array slices. This is not really what I want. Some of these answers are pretty old, though. It's kind of hard to know if this is still the case. I wonder if I could just map it and then collect it into a vec. There's got to be a better way to do this. If I did, let's see, let expected remaining as a card slice, and I make that a vec like this, then I should get a complaining. Let's do expected remaining. Expected, and then found a vec of cards, and then. So that's weird that I could do it here, but not inline. Okay. Okay, so this one will fail. So we're looking at test detect pair. Okay, so now we're up at the point where we have to actually implement detect kind cards here. So now I need to I suppose I could enumerate over the cards. And so if I do cards.iter, I need to enumerate, actually, because I need the index. If I do enumerate, that should give me, should be able to say find, and that should give us the card in the index. Because as I'm going, I just want to search the room like later and later in the so then I would say cards dot I think I would do cards and then do index to the end. And to see if this contains an other card whose card val equals card.val. Sorry, whose other card val equals card.val. So that would detect if it contains one. I would just need to map this with the count of how many of those appear. Let's do that. Instead of doing that, we'll map this with I actually want to fold this, I think. Yeah, we're going to fold it into a hash map. And this will give us the accumulated value in the card. We'll need to return the accumulated value, and then we will say see, this should be card. An argument is missing. Oh, we need to do that. And then we need the function after. I think that's right. Let counts is that. Fold initial value and then this function. I think I don't need that. Insert. I think I want to do update or whatever. Let's look at Rust hash map. If we can insert a new value, I think there's an update though. hash map, insert 1A, then get mute with that key. Entry, I think, is what we want, right? Gets the keys corresponding entry. Yeah, I think it's going to be something like this. Entry of that key and modify or insert. We'll use the card's value as the key, and then and modify C plus equals 1 or insert 1. And then this is okay, so we need to use standard collections hash map. We're not using itertools yet. Okay, cannot borrow a CC as mutable is not declared. This one is mutable. Okay, so our failure still is in detecting a pair because now we just have the counts. And the interesting thing here is this fold actually is a problem because we're going to do all the counts even if we've already found it. I think I want to do this in a way that bails out early. I mean, maybe just a plain for loop. Counts as a hash map of char to U32 equals hash map new for card in cards. Yeah, I think I'm just going to do this. Here we can do that. We're going to get the entry for that card. So this is counts.entry card val and modify or insert 1 if the counts that we just had, counts for get card.val is greater than, we need to unwrap here, is greater than or equal to the count that we were passed in, then we can return we still need to remove. Yeah, so we're gonna end up doing cards.filter. This needs to be a tuple. Cards.filter, where we remove this particular card from the set, and then true. Okay, get rid of that. We'll return cards.filter c.val not equal card.val. Okay, card is not an iterator, so, but that means we'll be taking an iterator. Let's actually use the real variable now. Do I need to borrow that? That seems weird. Okay, so now I want to return a string slice with the filtered list. I wonder if I can even do this. Like, does it need to be a new vec? And I feel like that kind of defeats the purpose of what we're trying to do. But I can't return a string slice that has elements filtered out of it, because otherwise when you get the next element, it might not be there. So I think I have no choice here to return a vec here. Well, let's do collect. Dot collect into a vec. And then do that. And I think I do that. No. Let's let remaining equals this whole thing. Then we'll do and remaining. Yeah, so this is a problem now, because now our vec has a borrowed card inside of it. And we can't do that. I mean, doing this everywhere is probably not what I want. That doesn't do what I want either. I think I would need cards.clone.into_iter. So this one should be a vec of card. Mismatch types, expect a vec of card, found a vec of a reference to card. Okay. All right. What do I need to do to make this work? Let's split out the types so I can just make sure that I have what I want. So cards was a slice of cards. If I do cards.clone, let's do copy equals cards.clone. I actually want the inlay hints here to help out, and I'm not going to bother with doing this in Vim. So I'm actually going to open up VS Code on this file. So that we can see what's going on here. Let's leave the errors over there. Okay, so if I do a copy, let's say I do A equals cards, right? So this is, they're both an array. If I then do into iter, then I get an iter of some type that we don't know yet. And the value is card. And then we filter on that. And we get a card. C.val not equal card.val. Let me do this and this. Cards. So when we filtered, now we're getting a reference, and this is what I don't quite understand. So could I do that? I can, but I feel like there's got to be a better way to do this. It's still something that I'm missing. So that gives me an impl iterator. Then I can collect this into a vec of cards. And now we've got a vec of card remaining. And so can I do this now? Move occurs because star C has type card, which does not equal the copy trait, which we can absolutely do. Cards can be copied. And so can hands, if that is needed. We also probably want partial equal because everything else is. Cannot be. This field does not implement copy. Well, okay, I'm gonna. I suppose I don't need that at the moment, but we want derive clone on here. Clone is not satisfied. We need clone and copy. Okay, cannot return value referencing local variable remaining. Okay, so this is what I was actually expecting, is that we've created some new vec right here, and then we're returning it. Returns a value referencing data owned by the current function. Which is true. I think now's the time where I need to consider what the return types need to be, because if I return a vec, then you can take ownership to it. But I don't want to return a borrowed reference because there's no owner, right? The ownership is dropped at the end of this scope. So let's change this to a vec of card. This is going to ripple our changes all over the place, but we can return remaining here. So then we go to 68. And this one also needs to return a vec of card. All right, so we're actually going to find, we're going to slash that, find ampersand card. And we're going to replace it with colon S. Let me see. How do I do this again? S slash. Yeah, this is what I wanted. The returns array of card. We're going to change that to returns a vec of card instead. And that can't be it. I thought there were more. This one right here needs to be returned as a vec of card. Same thing here. I'm not sure why my search and replace didn't work, but vec of card. Let's go to the top of it. Line 50. So this is now, it's kind of weird that I have to just collect it in. I wonder if I could just return, take a vec, return a vec. Seems weird. So this returns are remaining, so now I can borrow. Should be able to borrow that. Dot collect. Yeah. Now we're back at the same problem here where I would have to clone it like this. I hate it. And if I did reference here to card, is that going to mess me up everywhere? Because then I'd be creating new vecs, but not new cards. So I wouldn't need to do that. Expected card, found a vec of card. That is on 57. I would have to go through and change all my vecs to be borrows. But then this doesn't work. Okay, I have some cleanup to do, and I feel like I just need to start reading about, I think maybe reading the nom source code and how they work with string slices could help. However, nom doesn't have the same behavior that we do because we're trying to whittle down the results into smaller and smaller pieces. And so we may be skipping over indices. So we can't really be passing around this. I feel like we should be passing around vecs of cards everywhere. And if we did that, so this would take a vec of card. And then that one moves cards. Do I need to move cards into here? Don't think so. It still wants that. I really don't want to have to clone every time. That just seems like value borrowed here after move. Feels like that's inside. Yeah, okay. I'm gonna throw in the towel for now. I will hopefully get back, get some time to investigate and see what I can do differently here. But I do like the direction I'm going. I just don't know how to do it in Rust. So more reading is necessary. In any case, I appreciate you following along, and see you in the next one.